Right, so I said there were two information. I don't know what I'm saying. It's at this point in the day where you want to repeat yourself. You end up repeating yourself. Let's remove these annotations and show you a second piece of information that you can add to your study notes. So stratified, here's a simple cuboidal. Note in the previous video I said columnar. Hope you caught the mistake and corrected it. So it's a cuboidal epithelial cell. This is simple cuboidal epithelium. Simple cuboidal epithelium. They're collecting ducts in the kidney, the renal parenchyma. And then we looked at this loop of Henle, the thin duct, lined by simple squamous. And then I noticed on this side also loop of Henle. Now, you know, we can easily mistake microscopic structures when they become really small and refined. I do it all the time. So don't become stressed out or upset with yourself if that happens. Like we've been saying, baby steps, take it one day at a time, one image at a time. And if you look over here, what I want to highlight is this circular structure. It's perfectly captured. Side view, and it is a I'll say tubular, peritubular, because it's around a tubule, but it's actually around a collecting duct, so we'll say peridactylar. See, I correct myself. Peridactylar capillary. And how cool is that? And you can see that the basement membrane, in fact, is more pronounced here than it is in the loop of Henle. I wonder if I can... I did this earlier, didn't I? Really close. And then, you know, we can just show you. So you can see how thick that is. Basement membrane, right? And in all honesty, I mean, we're splitting hairs when it comes to telling you. I'm splitting hairs when I say, okay, there's the basement membrane, and then there, right on top is the cytoplasm of the simple squamous epithelium. It's not really easy to distinguish. What we can distinguish for sure is, and we can go color it in, is that guy. That's the nucleus of the flattened squame. And then biological extension, right? It's like, duh. I can't believe I just said that. You can deduce that that must be its cytoplasmic extensions on the side, right? Coming round. That typical squamous, where it tapers around and even possibly makes contact on the other side. Typical capillary morphology. Now the question that I posed in the previous video, examples of a simple squamous epithelium, where in the human body do we find them locations? It's going to be your capillaries, it's going to be your lymphatics, but the very small ones, and it's going to be the lining of the veins and arteries. Now, and it has a different terminology when we get to artery and capillary and venual and lymphatic. It's called an endothelial cell. Okay, an endothelial cell. We can say, yeah, I just wanted to actually draw a capillary. I wanted to draw a red blood cell inside. Okay, let's go have a look at the last, and that's the columnar, the columnar epithelial cell. So simple columnar epithelial cells, they are found in the gastrointestinal tract, lining the stomach, the duodenum, jejunum, ileum. It's been a while. And they're found in the colon, lining the colon, as well as in the endocervix. So let's go have a look at some of these images. Before we do, I need to shut the dogs up. So again, we have to bump it up. I can do this. It's getting taller, so from flat, medium to tallest, you could say. And there is no, or known that I know of, stratification. There is a pseudostratification in the respiratory epithelium, or the respiratory tract. And we'll have a look at that as well. Also rests on a basement membrane, also got the connective tissue underneath. The dogs are upset. So this is just a 3D graphic showing you how the columnar cells they push against each other and mold, and the nuclei tend to be basally located, and each individual cell rests on a basement membrane. This is just a scanning electron microscopic view of a columnar epithelial cell. I mean, you can see that rectangular morphology quite clearly. You can see it here. It's brilliant. This is just an incredible visual that they captured here. And even more amazing is the fact that they could visualize on the apical surface the cilia. So this is a respiratory epithelium, and you can see the cilia is an adaptation on the apical surface of the epithelium. Just absolutely an incredible visual that was captured here. See how close we can get to it. Just a wonderful, wonderful image to show you the incredible power, resolving power of an electron microscope, to be able to tell the difference or separate the spaces between those individual cilia. Just incredible. Okay guys, so here we have a typical standard routine stain. This is the hematoxylin and eosin stain, and you can see that the nucleus comes up a beautiful purple, and variations thereof. The lighter staining, less nuclear or chromatin material, that being a case in point, or there. And the darker the nucleus, the more dense the chromatin is. And this just reflects the different stages of nuclear activity. Now, the second component to the stain, and you guys will do this in the practical, is the eosin. And it stains up, it should, if it's a standardized and a good stain, it should stain up 3 shades. And I am seeing 3 shades, so I get like a orangey red, and then there's this purpley pink shading, and possibly maybe a lack of a third kind of shading, not to be confused with the shade and intensity is not the same thing. So one must be sure to see that must be sure you're seeing 3 shades of pink or orange, as they say. And I think it's fairly well stained and preserved. So what you're seeing on this side is basally located nuclei. This would be where the basement membrane would run. So it runs along here, and then you have your individual columnar epithelial cells, one next to the other. Quite clear. Split cell produces mucin. Mucin goes onto the top, lubricates the surface. But for all intents and purposes, these individual cells are separated. Visually, you can see them, and they all rest. You can see they're all individually resting on the basement membrane. Okay, so that's a simple columnar epithelium. Now the next slide I'm going to show you is a pseudostratified. Okay, so it's the trachea. It's been cut across section, and you can see the mucosal, the submucosal glands, the individual acini. Let's outline them for you so you can see them. This video session is not about tracheal microanatomy. This is not about teaching you the morphology of the trachea. This is about just looking at epithelium. So let's stick to that. So here's your basement membrane, would be. Okay. But now we've got something else going on here. We've got what appears to be nuclei on top of each other. So there's a nucleus. There's a nucleus a little lower down. Do you see that? And it's difficult to see, but there's one there, and then one slightly lower, and then one appears to be there. Oops, that went skew. And then one higher up. Now, in this particular stain, the nuclear stain isn't that great. Anybody tell me what this tissue is? looks so rough and angular and almost like it's got little pebbles in it. That in fact is cartilage. But sticking with the epithelium, that is a pseudostratified, and on the top it's got cilia. The next image shows it in much more detail. Okay, now this is really a great image, isn't it? Because the nuclei are so beautifully highlighted. This is the definition of pseudostratification, isn't it? What do I mean? Well, if we look at the individual cells, we can trace, for instance, this one. Let's take this one. We go along here, and if we trace the cell all the way to the bottom, we'll see that it actually does, over there, we'll make a little red cross, does rest along the basement membrane. In fact, all the epithelial cells come to rest on this basement membrane. Now, if it was truly stratified, it would be on top of another layer. There'd be two layers. So this is a pseudostratification, and they found this out by looking at it under the electron microscope, and they saw that all the cells, in fact, all of them, even though, you know, the nuclei appear to be at different depths. So you've got this little guy, and then you've got one higher up. You would think that is a two-layer. It's not. They're all resting on the basement membrane. That's where the pseudo comes in. And then if we zoom in even closer and we have a look at the apical, that means the surface right at the top of the cell, what we get to see is a incredibly fine arrangement of what appears to be little hairs, but are in fact cilia. And we looked at the electron micrograph of this, and you could see these cilia quite beautifully shown. They are dead straight, fine extensions that are embedded directly into the phospholipid bilayer. Quite a remarkable epithelium, and has a very important function in removing bacteria and pollution and any particulate matter that you might breathe in. It comes in through the windpipe, gets stuck in the cilia, and then like a escalator, it will, which way am I going? It will move it all up, and then it gets coughed up and out. Some people swallow, and it's destroyed. So it prevents infections. It has a very important function, this protective function. Okay guys, this was a long one. Hope you enjoyed it.